Hello and welcome to this video. It's going to go through Boolean operators and Boolean expressions. So we've used the term Boolean before. We know that Boolean is something that results in either true or false, or a Boolean variable can store the values of either true or false. A Boolean expression is an expression that results in either true or false. So it's not necessarily a variable or one, but it's something that we're going to evaluate, and the result is either going to be true or false. And to do that, to create these Boolean expressions, we need to use a Boolean operator, at least when we're dealing with primitive variables. And we use these Boolean operators primarily with primitive variables, so primarily with our ints, doubles, and chars. There are 6 Boolean operators. We can say that something is equal to something, not equal to something, greater than something, greater than or equal to something, less than something, or less than or equal to something. So really, when we talk about a Boolean expression, we're kind of asking a question. Is this thing equal to something else? Is this thing less than something else? Very, very important. Note that when we are checking if something is equal to something, we're asking that question. We use 2 equal signs. When we are giving something a value, we use 1 equal sign. They are not interchangeable. They result in very different outcomes. So make sure that if you are trying to check if something is the same as something else, you use 2 equal signs. I say equal to 2. It's not the number 2, but 2 and 2 equal signs. Whereas if I'm assigning something, I only use 1 equal sign. So let's take a look at that in action. I have some variables up here, x equals 10, y equals 25, and z equals 2.5. So if I'm looking at x greater than y, I'm really just asking the question, is 10 greater than 25? And the answer to that is going to be false. So this Boolean expression evaluates to false. Here, I'm asking, is 10 not equal to 25 divided by 2.5? So I have to evaluate this math problem before I can really answer that question. So I say, is 10 not equal to 10.0? And the answer to that is going to be false. Those two values are equal to each other. Next one I'm looking at, I have x plus y, x plus z, so 10 plus 2.5 less than or equal to 25. So is 12.5 less than or equal to 25? And the answer to that is true. Then I have y divided by x, so 25 divided by 10 is less than 2.5. Remember that I have an int and an int, so that's only going to result in 2 less than 2.5, and the answer to that is true. Then I have 5 equal to y mod x, which is 10. So is 5 equal to 5? And the answer to that one would also be true. And then I have 2.5 times 10, so z times x is greater than or equal to 25 divided by 10. So is 25.0 greater than or equal to 2? And the answer there is true. So I'm really just going through and asking questions. You want to always start by plugging in your variables and looking at what the actual value is before you go through and try to evaluate if that's going to be true or false. This is very simple and easy and straightforward when you're looking at numbers. It gets a little bit more complicated when we look at adding in characters. So how do we do these comparisons when we compare characters? So I look at different letters or symbols. We use what is called lexicographical ordering. So what is that? It's a fancy way of saying or alphabetically ordering something, but it's going to take into account if something is uppercase or lowercase. Because remember that Java is case sensitive, and capital A is not the same as lowercase a. So what Java does is it compares the values based on a numerical value. That numerical value comes from what's called the Unicode value of a character, and every character has a Unicode value. It's actually something that was developed originally as what was called the ASCII chart, or the ASCII code, the ASCII value. It was a set of characters developed in 1960, and it was kind of the American standard, so that all people that were working with computers used the same numerical values for each character. As time went on, though, ASCII was not large enough. It didn't include enough characters. Additional characters were added for different languages. So in 1991, they expanded the ASCII chart to include additional characters, and it became the Unicode character set. So to give you an idea of what that looks like, here's kind of the beginning and basics of the ASCII table. And so it's also the beginning, kind of which is part of my Unicode table, Unicode chart. Why do we need this chart? The reason, each letter has a decimal value. So when you go through and you compare characters, you actually compare the 65 for the capital letter A. If I was trying to compare the lowercase letter a, I would use the value 97. It's a lot easier now. I have number values, and I can easily tell, is 97 greater than or equal to 65? And go through and evaluate that way. So you do not, let me repeat this, you do not need to memorize these values, and you'll be getting a piece of paper to put in your binder or put somewhere safe that is an example of the ASCII chart, so that if you do want to go back and reference it, you can reference it. But you don't need to memorize these values. What you need to know is that the space up here is the smallest value that you're going to need to ever compare to something else, possibly. And then know that your letters, your capital letters, are all smaller or come before your lowercase letters. Some of you might find it easy to kind of remember that capital A is 65 and lowercase a is 97, if you're somebody who likes numbers. And that way it'll be a little bit easier to know, okay, well, if capital A is 65, then capital B has to be right behind it, and know that if lowercase a is 97, the lowercase letters follow after it. So in my comparisons, the capital A is going to be smaller than any of my lowercase letters, and my lowercase z will be bigger than every other letter. So let's take a look at some Boolean expressions with characters. So I've got two variables here, letter and other. One's a lowercase, one's uppercase. So if I'm saying other is greater than letter, the question I'm asking is capital B greater than lowercase a? And really what it's asking is 66 greater than 97? And we all know the answer to that is false. The next one, I'm asking if A is less than or equal to B. And when they're the same case, you're thinking just alphabetically. Is A alphabetically smaller than B? Would it come first in a dictionary? And the answer there is true. Yes, it would come first in a dictionary. Other equals B. So is capital B equal to a lowercase b? We know that is false because Java is case sensitive. They are not the same. They have different numerical values, and you look back at your chart. 66 is not equal to 98. Then I have letter is not equal to other. So is it true that A is not equal to B? And that is true. They are not the same. Is lowercase a less than capital Z? And the answer to that is going to be false. And if you want to look back at your chart, you can see that capital Z is 90, lowercase a is 97. So the question it's asking here really is 97 less than 90? And so that's false. And the last example, capital B greater than or equal to capital B. And we know that to be true. So a little bit more difficult when you're dealing with characters, just because you have to remember what order those characters come in terms of lexicographical ordering. Now, sometimes you're going to want to do more than one expression. You're going to want to combine these expressions, and that's called a compound Boolean expression. Anytime that I combine two or more of those expressions together, it's considered a compound Boolean expression. And what do I use to create these is a logical operator. There are 3 different logical operators. 2 of them I can use to actually create a compound expression. The other one is logical just because of it's one of the original logical operators. So I can use what's called an AND, which is represented in Java by 2 ampersands. And this is when I want the result to be true when both parts are true. So think of this way. If the expression for A was, do I have enough money to go to the movies? And the expression for B was, do I have a ride to the movies? If I don't have enough money and I don't have a ride, am I going to the movies? No. If I don't have enough money but I have a ride, can I get in the movie? No. Let's say I have enough money but I don't have a ride, can't go to see a movie. Both of these things have to be true. I have to have enough money and I have to have a ride to be able to go to the movies. And you guys have done and types of logical statements for years and years. And we're just looking at, are both sides of that and true? If both of them are true, my final result is going to be true. The next logical operator is an OR statement. So in case of an OR, you're thinking about it's either or. It's one or the other. And the symbol for this is drawn as just 2 big straight lines. And the key for that is between the backspace and the enter. It's that top, so you're going to shift and click on this key to actually type in the OR symbol. So if we think about this, we're trying to get to the movies. So the question is mom, if A represents mom being able to give me a ride, and B represents dad being able to give me a ride to the movies. If mom can't give me a ride, dad can't give me a ride, I have no ride to the movies. If mom can't give me a ride, but dad can, I can get to the movies. If mom can give me a ride, but dad can't, I still have a ride. And if they both can give me a ride, then kind of like a double bonus, I get to pick who I want to drive me to the movies. So I use ands and ors to combine Boolean expressions and create what's called a compound Boolean expression. And then my third logical operator is called a not, and you use the exclamation point. And you saw that when we looked at not equal to. Well, anything that results in true or false, I can also put a not symbol in front of. Sometimes it's called an inverter. If you took digital electronics, we called it an inverter. I'm flipping it. I'm inverting what it is. So if A was false, not A will be true. If A was true, not A would be false. And it goes through and flips that value. Let's take a look at some examples here. I've got some variables that I've defined up there at the top again. And a special thing to note here is that an AND has a higher precedence, which means that it's going to be evaluated first. So anytime that I have both of them in a statement, my AND will get evaluated first. So if we're taking a look here at this first compound Boolean expression, I'm checking if other is greater than letter and if num is less than 20. So is B greater than A? The answer to that would be false. So this would be false. And is 10 less than 20? True. But remember, for an AND statement, both of them have to be true. So the final result here is false. My next one, letter is less than or equal to B, or val is not equal to num. So that's going to be true or true, and my final result there would be true. And here's an example with just a not inside of it. So Notice I have my parentheses, so I have to evaluate what's inside the parentheses first. So is capital B equal to lowercase b? And the answer to that would be false. But I have my not on the outside, so not false is true. Got 3 more here. A is not equal to B and found. So notice that found up here is just a Boolean variable. So I'm just saying is that and false. So A not equal to B would be true. True and false though. Remember they both have to be true, so the final result here is false. Next one up, I have letter lowercase a is less than capital Z, or found, which is false. So I have false because lowercase a is greater than Z. False or false. Why my pen's not working here? False or false is going to give me false. And the last one, notice that there's an or and an and, so I have to be careful when I'm going through and evaluating, and I have a not outside here, so I have not B equals other, which is a capital B, or false, and 7 less than 10. So B equals B would be true, but I've got a not outside of there, so it's going to be false, or false, and is 7 less than 10, that's going to be true. I evaluate the equal sign first. False and true gives me false, so I get false or false, which is false. Now some of you might have noticed when looking at the chart that if I know something is false and it doesn't really matter what B is. If A is false, my answer is going to be false. In the same kind of way, when looking at my or, if A is true, it doesn't matter if B is true or false, because the answer is going to be true. And realizing immediately that if that first part is false in an and statement, so false and anything, or if that first part is true in an or statement, true or anything, is going to result in false and true. And this is what we call short circuiting. So what it says is that when I go through a compound Boolean expression, and I don't have to really check the second half of it, I don't have to evaluate the second part of it, because the answer has already been determined by what was at the beginning. So looking at the first 2 examples from the previous slide, once I looked at B greater than A, and I know that that is false, it really doesn't matter what this is. False and true, or false and false, is going to result in false. Kind of in the same way, A less than B, that gives me true, and it doesn't matter what comes after that, because true or true, true or false, both of those result in true. And that's what we call short circuiting. And it is something you'll see, and it saves the computer time, as if this was a heavy calculation that it had to do. Let's say this was a complex math problem. Once I know false and, I don't need to do that extra evaluation. And this can also help us in not causing errors in our program. And we'll take a look at that in the next few videos. So, good luck.